Quiz 3 will be Friday, November 11th. It will have 8 questions. There's an optional practice quiz 3 on Delta Math. Here's the practice quiz that we did in class. There's 4 terms in this equation. I'm going to write down the derivative of each term. The first term is y. The derivative of y with respect to x is what I just wrote. The next term requires the 4 bells. The exponent 2 times the negative 2 is negative 4. The y gets copied. The 2 becomes a 1 exponent. And we also have to multiply by the derivative of y with respect to x, because you could have parentheses around the y, and this 4th bell is the derivative of what's in the parentheses. Now we're on the equal sign. The 3 and the negative 1 get multiplied. X to the 3rd becomes x to the 2nd. And we're technically going to multiply by the derivative of what's in the parentheses that I just wrote, the derivative of what is in the parentheses with respect to x. I'm going to be erasing this, though, because dx over dx is 1. Then we have minus y cubed. The derivative is minus 3y to the 2nd times the derivative of y with respect to x. So we're using the chain rule every time. The 4th bell is the derivative of what has parentheses around it, or what could have parentheses around it. And in this case, that 4th bell does not need to be written. So now there's 1, 2, 3, 4 terms. I'm now going to write every term that has a dy over dx, all the ones I underlined. So dy over dx minus 4y dy over dx. This term, because it has dy dx, has to move to the other side of the equal sign. It turns into a positive 3y squared dy over dx. And then on the other side of the equal sign, we write every term that does not have dy over dx. And this is the only term that does not have dy over dx on the right side of the equal sign. Then every term on the left side has dy over dx, so we factor that out of 1 minus 4y plus 3y squared. So dy dx that's common is now factored out, leaving a 1 minus 4y plus 3y squared in parentheses. Copy that. And the last thing we do is to answer the question. We say the derivative of y with respect to x is what's written on the right side divided by all of this stuff in the parentheses. Dividing both sides of the previous equation by 1 minus 4y plus 3y squared. A right triangle has legs of 3 inches and 4 inches. So use your imagination. Here's a right angle. But the sides are changing. I'm going to draw another right triangle. The side that's 3, I'll call that x, and the side that's 4, I'll call that y. The short leg, that would be the 3, is decreasing at a rate of 8 inches per second. That means the derivative of the short side with respect to time is 8 inches per second, but decreasing, so it's negative 8 inches per second. The long leg is shrinking. The long leg is this vertical, 4 is longer than 3, so the derivative of this side with respect to time is 5 inches per second. But that side is also shrinking, so that's a negative. If either of the sides were growing, we would have made the derivative positive. What is the rate of change in the area? So the derivative of the area with respect to time is what we're trying to find. What is the rate of change in the area? And that's We're trying to find that when x is 3 and y is 4. So we need a formula for the area of a triangle. The area of a triangle is 1/2 base times height. And now we're going to differentiate implicitly with respect to time. The first term is a, so I'm going to write the derivative of what I just traced in red with respect to time. The other side of the equal sign is called a product. The derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. I'll repeat. The derivative of 1/2 xy is the first times the derivative of the second. These are with respect to time, plus the second times the derivative of the first. The derivative of 1/2 x is not 1/2. It's 1/2 times the derivative of x with respect to time. If it was derivative with respect to x, I wouldn't write that because it would have been dx over dx. All derivatives and related rates are with respect to time. So now that we've differentiated, that means we took the derivative of both sides, we plug in numbers. We can't put a number where it says dA over dt because that's equal to question mark. We're trying to find that. Copy 1/2, where the x is, we put 3. Read all the stuff I wrote. Where the dy over dt is, we put -5. We're just plugging in the numbers that are listed above. Plus sign from the product rule. Where the y is, we put 4. It's right there. Copy that 1/2. Where the dx over dt is, I see that's -8. Now some arithmetic. The rate at which area is changing with respect to time, 3 times 5 is 15 times 1. Well, that's -15 over this 2. Plus 4 times 1 times 8 is 32. It's actually -32 over the 2 times 1 times 1. And -15 plus -32 is -47 over the common denominator. The area of this triangle will be measured in square inches. That's the top letter. Per, T is the bottom letter, which stands for time. Time in this problem is in seconds. And -47 over 2 square inches per second, which is the same as -23.5 square inches per second. There's only one related rates question on the quiz Friday, but you should try this one. It's just like the last one, and make sure you get this answer. Just do it like the last one. This one's a little bit different, so I'm going to do this one with you. Remember, there's only going to be one related rates on the actual quiz. Here's another one for practice. Don't forget to practice the one that was on the last slide on your own. A right triangle has legs of 36 inches and 48 inches, and the sides are changing. So here's where the sides are changing. 36 is smaller than 48. I'm going to call that X. 48 is longer. I'll call that Y. The short leg is increasing. The short leg is X. The rate at which the short leg is changing with respect to time is 3 inches per second. And that's a positive because increasing. The long leg, that's the 48, which is labeled Y, the rate at which that leg is changing with respect to time is 6 inches per second. But that gets a negative because shrinking. The hypotenuse, I'm going to call that Z because the question is, what is the rate of change of the hypotenuse? The derivative of Z, that means the rate at which Z is changing with respect to time, is we don't know. So this time we don't use the area formula. We use the Pythagorean theorem, x squared plus y squared equals z squared. And now we're going to differentiate each term. Using each term requires the four bells. The derivative of x squared is 2 times 1 times x to the first power times the derivative of x with respect to t. The derivative of the next term is 2 times 1 times y to the first power times the derivative of y with respect to t. After the equal sign, the derivative of z squared is 2 times 1 times z to the first power times the derivative of z with respect to t. And now the next step is plug in numbers. 2 times the x was 36. dx over dt is positive 3. Copy the plus, copy the 2. Y is 48. dy over dt is negative 6. Copy the equals, copy the 2. I'm going to talk about how to get that number in a second. And dz over dt gets copied because that's the question. In this original triangle, we were, before the shrinking and increasing, it didn't tell us what z is at that time, but we can figure that out because we know that 36 squared plus 48 squared has to equal this hypotenuse squared. A squared plus b squared equals c squared. $36 squared is $12.96. 48 squared is 2304. I don't know why I use c instead of z, but it doesn't matter. 1296 plus 2304 is 3600. This equals c squared. That means c has to be the square root of 3600. The square root of 3600 is 60. So in this original triangle, I labeled 48 and 36 because they were given, and I could have put a 60 there even though it isn't given. And it's important because that z has to go there, 60. That's what z is when x is 36 and y is 48. Now we're going to solve for dz dt because that's the question. The question is, what is the rate of change of the hypotenuse? 2 times 36 times 3 is 216. 2 times 48 times negative 6 is negative 576. And on this side, we have 120 times dz over dt. 216 minus 576 is negative 360. Copy everything else. And now I'm going to divide both sides by 120. Negative 360 over 120 equals dz over dt. Negative 360 over 120 is negative 3. And z, the hypotenuse of this triangle, will be measured in inches, just like the legs are measured in inches. Z on top is inches. T is time. In this problem, time is seconds. So that's the final answer. Rewind and play this part again if I went too fast. A, B, C, and D in the figure below are bounded by the graph of the function f. This wavy function is called f, and the x-axis. The area of region A is 8. The area of region B is 17. It means inside here, between here and the x-axis, there's 17 square units. The area of region C is 23, and the area of region D is 6. So the integral from negative 8 to 5, This is tricky because here's -8 and 5 is here because that's 6, 7, 8. So the integral is the areas. Well, the integral is the signed area. So it's going to be 8 plus this integral. The area is 17, but the integral is -17 because that region is below the x-axis. Plus this integral is -23 because that region is below the x-axis. And we would add a +6. We would if it said the integral from -8 all the way up to +8. But it doesn't say that. That's not a +8. So we're stopping here. 8 plus -17 plus -23. The 8 is a +8 because that area A is above the x-axis. So the final answer is -32. This line means each term above the line gets divided by x squared. The 24x to the 4th gets divided by x squared. The next term, -7x squared, we divide by x squared. The next term, +7, gets divided by x squared. So we have the integral, and there's a dx there. But 24x to the 4th over x squared is 24x squared. This is algebra. 7x squared over x squared is just 7. 7 over x squared can be written 7x to the -2. There's 3 terms, so I'm going to write 3 integrals. The integral of the first term minus the integral of the second term. Oh, I have a mistake. Every integral has to have its own dx. What I mean is the dx has to also distribute. So the second term is minus the integral of 7 dx plus the third term. We have the integral of 7x to the -2 dx. And there's a couple formulas on your formula sheet that are needed here. One is the integral of x to any number dx is x to the exponent plus 1 over the exponent plus 1. And there's really a plus c, but I won't put it here. And the integral of dx, just if that's all you have, that's just x. Both of these are supposed to say plus c, but I'll worry about that later. So you copy the 24. The integral of x to the 2 is x to the 3 over 3. Copy the minus, copy the 7. The integral of dx is just x. Copy the plus, copy that 7. The integral of x to a number is x to this number plus 1, -2 plus 1, which is -1, over that same exponent is also the denominator, just like these 3's. Plus c is part of the answer. 24 over 3 is 8. So 8x cubed minus 7x. This is 7 divided by -1, which is -7. And next to that, we still have x to the -1. And that could be the answer. But if you don't like to have a negative exponent in your answer, that third term can be written as 7 over x to the first power. Plus c is part of the answer. So we just needed these 2 formulas. The plus c that's in every formula, we just need that one time at the very end of all this. The 1/6 goes to the left of the integral sign, leaving 1 over the 4th root of x. But the 4th root of x is the same as x to the 1/4. And since it's 1 over x to the 1/4, we bring that to the numerator and make it x to the -1/4. Don't forget the 1/6 to the left of the integral sign. And just like we did in the last thing, last question, the integral of x to a number, this number right here, dx is x to the whatever the exponent is plus 1 over n plus 1. So this integral is x to whatever -1/4 plus 1 is, which is 3/4, over 3/4. 1/6 just gets brought down. Plus c is part of the answer. Dividing by a fraction is the same as multiplying by the reciprocal. Dividing by 3/4 is the same as multiplying by 4/3. 1/6 just gets brought down again. 1 times 4 on top, 6 times 3 on the bottom. X to the 3/4 plus C. But 4/18 can be reduced to 2/9. So that's the final result. By the way, remember this formula cannot be used if n is -1. But here n, the exponent, is not -1. That's why we use this formula. Two terms, so we write two integrals. Don't worry about the 2 and the 3 right now. The integral of the first term, which is 3x squared, don't forget dx, minus the integral of the second term, which is 4x, don't forget dx. And we're going to use the same formula. We just used it. The integral of x to a number is x to that exponent plus 1 over 3, x to the third over 3. That 3 in front gets brought down. The integral of x to the first is x to the second over 2. The minus 4 just gets brought down. In problems with numbers attached to the integral symbol, we don't write plus c. Instead, we put a bracket with those numbers attached. 3 over 3 is 1, so that's 1x to the third, minus 4 over 2 is 2, with x squared next to it. Bracket 3, 2. That means the next thing I do is I write everything here with the number up on top in place of x. All the x's would get replaced with 3. Then minus the quantity. Then after the minus parentheses, all the x's get replaced with whatever number's down there. So 2 to the third minus 2 times 2 squared. And now it's just arithmetic. 3 to the third is 27. 3 squared is 9 times 2, that's 18. 2 to the third is 8. 2 squared is 4. 4 times 2 is 8. Well, 8 minus 8 is 0. 27 minus 18 is 9. So it's 9 minus 0, which is 9. Two terms, we're going to make two integrals. The integral of the first term, don't forget the dx has to also distribute, and then minus the integral of the second term, which is 2x, don't forget dx. But after the minus, it's easy. It's 2x to the 2 over 2, just like the last problem, because 1 is the exponent. But for the first integral there, we have to use integration by substitution, where we let u equal this exponent, 0.5x. So derivative of u with respect to x, the derivative of a number times x is just the number. So du equals 0.5 times dx. Or you could say du equals 1/2 dx. 0.5 is the same as 1/2. So dx, we need it to say 1/2 dx. So what we say is you can write in a 1/2 here, as long as you write the reciprocal of that red number out here. This is the whole lesson we had called integration by substitution. And then we did this thing called copy and substitute, a phrase I said many times the other day. So what I mean is the 2 gets copied, the integral symbol gets copied, the e gets copied. The point 0.5x does not get copied. That gets replaced with u. The 1/2 dx, none of that gets copied. That gets replaced with du. And then another formula on the formula sheet reminds you that the integral of e to the u du is e to the u. Don't forget there's a 2 to bring down. And after the minus 2x squared over 2, that's just x squared. The u turns back into 0.5x. Instead of plus c, we put a bracket because there's numbers to use here, 2 and 0. Everywhere there's an x, I'm going to put the 2. 2e to the 0.5 times 2 minus 2 squared minus parentheses. Every x gets replaced with 0. 2e to the 0.5 times 0 minus 0 squared. 0.5 times 2 is 1, so that's 2e to the first, minus 2 squared, that's 4, minus 2e to the 0, because 0.5 times 0 is 0. And that can be ignored because 0 squared is 0. So we have 2e to the first, just 2e, minus 4, minus 2, because e to the 0 is 1. 2 times e to the 0 means 2 times 1. So final answer is 2e minus 6, because minus 4 and minus 2, combine those. 2e minus 6 is the final answer. This 5 over 3 can go to the left of the integral symbol. And something to the something inside a cube root means whatever's inside there can be written in parentheses to the 1/3. The x that's in the front, I'm going to put it here instead of in the front. And don't forget the dx. So integration by substitution. Let u equal the stuff inside the parentheses, because the derivative of u with respect to x is 10x plus 0. So du equals 10x times dx. That means we need a 10 written here. This says x dx, but we need it to say 10x dx. Yes, you can just write the 10 in, as long as you also write 1/10. So 1 times 5 over 10 times 3. And now we say copy and substitute. Copy the integral symbol. Do not copy what I'm putting a green box around, because that gets replaced with u. The 1/3 exponent, you do copy that. You do not copy what I'm putting this purple box around, because that gets replaced with du. And then the formula we've used a few times already is the integral of u to a number, du, is u to that number plus 1. 1/3 plus 1 is 4/3. It's u to 4/3 over 4/3 plus c, don't forget 5 over 30, but 5 over 30 can be reduced to 1/6. Dividing by 4/3 is the same as multiplying by 3/4. Don't forget the 1/6. So we have 1 times 3 over 6 times 4. And that u is actually 5x squared plus 3. So this means actually 5x squared plus 3 to the 4/3. And don't forget plus c. 3 over 24 can be reduced to 1/8. So 1/8, 5x squared plus 3 to the 4/3 plus c. You can use the 4 bells to find the derivative of that to make sure it's the original. Notice we did expect to get the answer in simplest form, which is what I put a box around. 1/8, 5x squared plus 3 to the 4/3. And here's another practice problem that you can look at all the work, but I did put this up here to remind you that you can also get the answer to this by graphing y equals 5, and then finding the area between y equals 5 and the x-axis from x equals 2 to x equals 7. So you can do all this calculus and get 25, or you can graph this horizontal line, y equals 5, and the integral means the area between y equals 5 and the x-axis from x equals 2 to x equals 7. And the area of this 1, 2, 3, 4, 5, 10, 15, 20, there's 25 square units. So the answer can be found using calculus or using geometry. Here's another one to try. I won't do this with you, but you should try this. And just write the problem down and then look away from the video, because here's all the steps. And the final answer comes out to be -62, but make sure you can actually do it on your own without copying this. And you can do it on a calculator, but I don't have time to explain the buttons to press. You can maybe figure it out or Google it.